today's video, we are going to talk about one type of proof, and this proof considered one of the easier type of proof, and that is trivial proof. So what is trivial proof? To explain a trivial proof, here's a truth table for a conditional statement. We have an implication of the form P implies Q. It is only going to be false when the hypothesis P is true and the conclusion Q is false. If you notice, whenever the conclusion Q is true, the entire implication is true. So if you are given if and then statement, and you recognize that the conclusion of the statement is always true, that the hypothesis actually doesn't even matter, then you can use that to justify the entire implication is true. And we call this a trivial proof. So a trivial proof of P implies Q is one in which we show that the conclusion Q is always true.
So for example, let x be an element of natural numbers. If x is an odd number, then 2 is a prime number. This statement is if and then statement. So first, we should look at our conclusion if it is true so that we can use trivial proof. Our premise here is x is an odd number, and our conclusion is 2 is a prime number. Looking at our conclusion, we can say that 2 is a prime number. It is a fact, because when we say prime number, it is a number that only divisible by 1 or itself. Therefore, our conclusion is always true. Hence, we can use trivial proof. So how are we going to write our proof? So let's say if your assertion that you're trying to prove start with an assumption like we started with let x be an element of natural number, our proof is going to start with that same assertion, even it doesn't particularly matter. So proof, let x be an element of natural number. So in this point, we point out that regardless of whether x is an odd or even, we don't even really need to bring that into this. All we need to do is to explain that the conclusion is always true. So let x be an element of natural number. Since 2 is a prime number, the conclusion is always true. So this conditional statement is trivially true. So notice, we didn't make any mention of the hypothesis because in trivial proof, we don't need to mention the hypothesis because it really doesn't come into play. 2 is going to be a prime number whether x is an odd or even.